So, in our last part, in the beginning of cumulative frequency, a term we haven't actually explained yet, we looked at estimating the median from grouped data. Okay, and we did it by working out where the middle piece of data was in terms of the 31 bits overall, finding that it was the 16th, and then locating which interval it was in, and then where within that interval it lay. So that's one method. The other method is by graphical means. And what we're going to do here is we're going to look at how we can use this information to try and gain some further understanding of how the data is behaving. So, should have used a pencil there, apologies. So, what I'm going to do here is plot a series of facts, and I'm going to plot them in order to try and estimate what's happening between those facts. So time in minutes is along the bottom there. And I'm going to plot a series of facts on my y-axis. Now, what I want to be able to do is to locate the median piece of information. So let's put all the data in order. And let's do it by doing the following. There are 31 bits of data, so let's put all the data in order down there. Now, after 4 seconds, or 4 minutes rather, 3 bits of data have been achieved. So after 4 minutes, 3 bits of data. That is a fact. After 8 minutes, how many bits of data have been counted? It's not 7. It's actually 10 bits of data. If I'm putting them in order, I need the first 3 and then the next 7 to count. So it takes me to 10 bits of data. So at 8, I plot 10. After 14 minutes, I now know that 22 bits of data will have gone by. So let's get those in the same order as well. So up to 14 along here. There we go. After 20, I know that 27 have gone by. After 30, I know that 29 have gone by. And after 60, I know all 31 have. Now, what this shape has done is told me that the first 3 bits of data lie here in this interval 0 to 4. Now, we don't know if all those bits of data in that interval from 0 to 4 minutes all come right at the start, 1, 2, 3, or right at the end, or if they're spread out equally. We know they're in there. Then, what we were doing on part 15, when we identified this interval as having the median, was we tried to make an assumption about where the data lay within that interval. And from that, we then tried to go, well, let's assume it's the middle bit, the 6th bit out of 12 was in the middle. Now, watch how I can show you how this data might behave in between the intervals. See that smooth curve that I've drawn? What it's doing is, it uses where each point lies and where the next points afterwards lie to show you how to bend it. Now, how you bend it then, it's trying to estimate the shape. It's trying to estimate where the data lies. So this curve is a way of us estimating where values lie. Now, we know that there are 31 bits of data. So on my curve, if I go to 15.5 on this axis, which I haven't given a name yet, I can use this curve to try and estimate the median. And you'll see it comes out about 11. So here, in the previous part, we assumed it was all equally spread out. Now that may be the case. And in fact, our line, because it's nice and straight between here and here, does suggest that. That's why we got the same value in both methods. So this curve is a way of us estimating what's going on. Now, this here is the frequency all the way up to the end. Adding the frequency up to the end is called the cumulative frequency. And this column we worked out is called the cumulative frequency. Now we plotted the end of the time interval against the cumulative frequency. And that gave us our curve. And from our curve we went to halfway into the data and drew across and down to find where the median lies. Now, I'm going to spend a minute now doing the hard bit, which is to explain why the curve versus just guessing. But the reminder, it's end of the interval against cumulative frequency. Plot those points, cumulative frequency going up, find the middle of the values and then read off. Pause now to have a look at that again and think it through before I explain this. So, we knew on the previous part that the data lay somewhere between 8 and 14, and we guessed it was the middle at 11. Now the curve we just saw had a pretty straight section, which would suggest the data is nicely spread out along it. But the curve between 2 points is affected by the next point. So if the curve looked like this, you can see it's not the same as the straight line. So this method is the straight line approach, but if the data points either side are different, it changes the shape. And we can go to some really extreme ones. So here, for example, look how late that curves up compared to the estimating it evenly. You have some big gaps here. So actually the curve can deviate quite a lot. And that's why it's a really good method for estimating the median. Now, plot endpoint against cumulative frequency. Join the curve up smoothly. Find halfway to find the median. This is the basics of cumulative frequency. But in part 17, I'm going to introduce you to the interquartile range and more values and things you can find from a cumulative frequency curve. What I suggest you do now is go off and try some questions where you're just getting to this stage. Get familiar with cumulative frequency up here, the other variable along here, plotting endpoint against cumulative frequency.